Hello everyone, welcome to part 1 of module 6 data communication. So module 6 this is the introduction video and we will be seeing some of the basic concept on switching here. So if you are looking at module 6, the first half of your module is basically talking about a concept called spread spectrum, like that frequency hopping and direct sequence spread spectrum concept. And the second half we are actually discussing a topic called the switching, within a given network how information is being propagated from one node to another. You can see that it's a what we have is a www worldwide web, right? So where the devices are connected throughout the world, so how the information which is being sent from your machine is exactly delivered to the destination, which may be located at some different part of the world. So what is that switching process which is happening on the way for your information? So that is a switching technique, and basically we have two types of switching techniques. The communication by means of a permanent connection, which is already made before starting your communication. That is what is called a circuit switching. So that means based on a fixed predefined circuit we are trying to switch our information. And we have a different concept called the packet switching, where there is no predefined circuit available, and on the way the information will be taking its own route. And also, instead of sending your information as a whole message of some huge size, what we will do is we will divide that information into smaller packets, and those packets will be communicated over the internet. So that is why it is called the packet switching, in the sense we are dividing information into different packets, and these packets are getting switched over the internet, and there is no guarantee that all the packets that represent a particular given message is going to take the same route. They may be taking different route also. So everything is dynamically allotted. That means the route which you are supposed to follow, you don't know in advance. On the way, which is traffic free, accordingly you will switch your route, or which is efficient. And there are different criteria. Based on that we will select the best route, and we will optimize. We will try to optimize many things, the overall cost involved in your communication, the waiting time in terms of traffic congestion, etc. By considering such a number of parameters, there is an optimized algorithm that is working on the background, which is going to help you to route your information through or switch your information through the best path. So that is other category called packet switching, and we have some combination of both this a concept called virtual circuit, where some concept from circuit switching as well as packet switching are being combined, that you can see. So these topics are basically, you can see, it's a second half almost, but compared to that spread spectrum, this is something more important for you. So I thought of starting with that second half, because if you are looking at your the advanced course also, that very good base on the second half is what is needed. Okay, so at the same time the first half is equally important. That if time allows, I will be moving on to the first half, because as it is module 6, I don't know how much I can complete before your exam. So first I thought of giving more attention to that second half, so that is why I am starting with that. So the concept is switching. So let's see. A network is a set of connected devices, that you know, right? Whenever we have multiple devices, we have the problem of how to connect them to make a one-to-one communication possible. So how we are going to connect different devices, and we have that connection by means of your transmission media. We have one module particularly dedicated to see all the transmission media, like coaxial cable, optical fiber, and of course twisted pair, those things. And even we have wireless media also. So that is a way we are having connection between two devices which are almost, some nearby devices you can connect in that way. Now the question is, if the devices are somewhat located far away, now how you are going to give a complete connection between them? Means they may not be in it is not possible for us to reach from one device to another in maybe in a single hop in the sense jumping say from one device to another. It is not possible for you, means they are not directly connected. In between many devices will be coming on the way. So that is a way. So that is a general scenario. So look, think about the connection of the devices worldwide. So how they are getting connected, in that way you have to think. It is, we are not talking about just a connection say between two nearby devices, or just connection between devices say within an organization or within your campus. It is not the case. We are just thinking about the general scenario where we have different devices which are being connected within your organization or your campus, or similarly there will be another small network that you can see in some other college or whatever it is. And in the communication is even possible between these two organizations also, these two firms, like that. So in that way you have to see the general connection of devices which are spread over this world. On different parts you have different clusters of devices which are getting connected, and all together there is some kind of backbone network which is linking everything together. And what is happening for your information when you are trying to access say your Gmail server or your Yahoo or some other web server, whatever it is, or Google server, Facebook, where all those things are located at different parts of the world, and how this communication is happening. So that general scenario we are trying to see. So one solution is to make a point-to-point connection between every pair of devices. That is, you can think of a mesh topology, or between a central device and every other devices by means of a star topology. I think in our data communication software we didn't touch the concept of topology, but you may be saying it at different points. So topology simply means the way in which you are connecting your devices each other in your computer network. Is it a computer network terminology? So that is saying about the method of interconnection. So for example, if you are thinking about this mesh topology, it's a very straightforward connection. For example, suppose you have 10 devices and they want to communicate each other. So what we can do, you can make a connection between all the pair of 10 devices, so that whoever say device 1, device 2, device 3, etc., device 10, all of them want to communicate each other. So what you are going to do, simply you are going to have a connection between every two devices. So device 1 will be connected with the device 2, device 3, etc., device 10. Similarly 2 is also connected with the 1, 3 and all other devices. So in that way, as it is, there is a direct straightforward connection between every pair of devices. You can have a communication directly without any problem. So that is a very simple approach. But what is the problem there? If there are 10 devices, see how many connections are needed. Between every pair you need a connection. Okay, so 10 C2. How many ways you can select 2 out of 10 C2 ways. So 10 C2 connections are needed. So that is a limitation. For 10 C2 it is fine. Now think about our current scenario. See how many devices are getting connected to the internet. In your home itself, there may be some 10 devices they want to connect with to the internet. When this IoT and everything is coming, everything is getting part of internet. So in that case, see we can't even say it's some kind of countless, that many number of devices are there as part of your internet. So everybody want to get connected each other. Because from your machine, whoever you want, who is located at any part of the world, the communication is possible now. That means there is some kind of connection between your devices and that very remote devices even. So with those many billion number of devices, if you want this that many NC2 number of connection, it is not a practical thing. Okay, so that is a problem. But if you are looking at a very small geographical area, so typically normally we call it as something called local area network, a very small area. And to the next level we have a metropolitan area network, MAN network, and then we have the wide area network. So that is our current world wide web kind of thing. That's the entire connection. So here we are thinking about that whole connection communication, and that is possible. For a small geographical area, typically called as a local area network, you can think about mesh topology if you want such a very robust connection. Okay. Now another way is star topology. Simply just like a star, there is a central node who is capable of making this communication possible, and to this central node all the devices are connected. like this. And okay, now I'm not able to, so just I'm just trying to draw this using this mouse arrow. It is the pen I find some difficulty to use. Okay, so it is like this. You can imagine, I think, just like a star, there is a central node at the middle, and to the central node all the individual devices are getting connected. Now two devices want to communicate each other. One device will be sending information to the central node, and that central node will forward it to the appropriate destination. Okay, so that is the thing. So again, it is also having same difficulty when it comes to a large number of devices. Okay, so it is not a practically feasible solution for when it comes to the wide area network, and these methods, however, are impractical and wasteful, of course, when applied to very large network. So the number and the length of the links require too much infrastructure to be cost efficient, and the majority of those links would be idle most of the time. So that is another problem. It is not about the cost efficient. First of all, it is not a cost efficient solution, because you need that many links, that many complicated infrastructure is needed on the background. And now the second issue is, suppose we have 1,000 devices and you connect them by 1,000 C2 connections, and 1,000 into 1,000 minus 1 by 2, so that many connections are there, and see how many devices want to communicate each other at any instant of time. Maybe only few. See, now what about the remaining 1,000 C2 resources you given for your entire communication? Out of this 1,000 C2, maybe some 10 links will be active at any time. The remaining will be just a waste. So when you are means allocating more and more resources, you should ensure that all the resources are utilized efficiently. But in this case, such a guarantee is again not assured. Now, other topologies that you can think about is, of course, a bus topology, where there is a common shared bus. To this bus, all the devices are getting connected. Now, okay, some disturbance in between. Okay, so the third solution or some other different topology you can think about is the bus topology, where to a common shared bus the devices will be connected. Okay, and now also how long the distance matters. So other topologies like bus are ruled out because the distance between the devices and the total number of devices increases beyond the capacities of the media and equipment. So definitely the number of devices which are to be connected to the bus will increase, and also there are some other difficulty with this bus topology. If there is a single point of failure at any part of the particular shared link, definitely the whole communication process will stop. Okay, so that is the thing. Now, a better solution for this is something called switching, which is a kind of combination of all the topologies, everything. Okay, so a switched network consists of a series of, we will see what it is, a series of interlinked nodes called switches. And the switches are capable of creating temporary connections between two or more devices linked to the switch. So that is very important. The connection is not permanent. Just between two devices which are connected to the switch, they are making some kind of a temporary connection if it is needed only. Okay, and that switch, the way in which it is configured, everything, if time allows, we will see. And that time you can see that it is not like a bus or star or mesh topology where we have permanent wires, everything dedicated. It is not like that, but to the switch the devices are connected, but still between a pair of devices, if we want communication, then only the connections will be made inside the switch device, and we will see that, then it will be clear for you. So in a switch network, some of these nodes are connected to the end system. That is, so some of the switch devices are connected to the end system, that is the computers or the telephone, whatever it is, that end devices, and others are used purely for the routing purposes, so routing of the information which you are trying to communicate. So it is something like this. So this is a switch network we are having, and to the switch network we are connecting all the end devices. So okay, the end devices are sometimes called the stations, and the switch devices are sometimes called the nodes. So that is a terminology that is used in the William Stallings textbook, but that is not a fixed terminology. In other textbook you may be referring them using some other terms also. Basically we have these end devices connected called stations, and the switch devices, that's all. It is called as nodes in this text. So here you can see that there are 7 such switching nodes and A to F some devices connected. Now see the device A, say want to communicate something to F. What it can do is it can send the information to switch 4. Now from switch 4 it will be router through 5 and 6 to F, or through 7 and 6 to F. So that is the flexibility we are getting. But if you are having a bus topology something, just a single connection will be there, just a common shared bus. And if anything happen to a particular part of the bus, the entire process will be disturbed. But even though suppose the link say 4 to 5 is failed due to some reason, definitely we have an alternative path, that is 4, 5, 6. So that is that makes this communication more reliable, as there is a number of paths between a pair of devices increases more and more by means of some kind of cycles, everything. And if you want, you can make everything every switch nodes to connect each other by means of some okay, so that about the general scenario. So that is the thing, if A want to communicate with F, it can choose either this path or this path. Okay, now that's all. We will see some terminologies with this. The device attached to the network, as I already told you, may be referred to as stations. Now the stations may be computers, terminals, telephones or other communicating devices which want to communicate each other. We refer to the switching device, whose purpose is to provide that switching, that communication. And the intermediate switches are actually providing the switching, in the sense whenever some information is coming to that particular interconnecting node switch, it will be connecting it to some other outgoing link, so that a kind of just like a switch. Okay, so that it just like in the previous example, from A, when the information is coming to switch or switch node 4, but it can enable that outgoing link to be switch number 5 or switch number 6, sorry 7 I think. Okay, let me see that diagram. So whenever that information from A is coming to 4, switch number 4, that it can communicate that information further to this using this link or this link. Okay, or accordingly the particular device will be having 2 ports, and within this dynamically or temporarily some connection will be established on that time, say from this link to this link or from this link to this link. It is not some prefixed connection. Okay, so that is why that process is actually called switching. So just these two, I mean there will be some set of incoming ports for this device and some outgoing ports. In this case you can see that there is a single device connected to this, so incoming port is 1. So here you can see that 2 devices are getting connected to the switch. Okay, and outgoing links will be this many, so that it can decide like which are to be connected to the incoming and outgoing, whatever it is. So whenever this is coming to this particular port, what will happen, it want to communicate this to F, so it will select this as the outgoing link, and accordingly a temporary connection will be enabled between these two by a kind of so that is what we call as switching. Okay, and if it want, it can send that information to this one also, this one also. Okay, that will be dynamically chosen by looking at the traffic of if this path is something more congested, it can choose this path. Or even if it is sending to this switch number 1, it is not going to be delivered here, so that is a problem. So if it want to deliver the information to F, accordingly it will run some algorithm on the background, and it will choose either this 5 or 7 as a next hop. Now the nodes are connected to one another in some kind of topology or transmission link. In the previous diagram there were no fixed topology, but if you want, I already told you that interconnecting nodes, I mean switches, can be connected by means of mesh topology or star topology, whatever it is. Okay, but it is a kind of backbone network, and always if you are going with some connection like a mesh or a star, it is more and more reliable and robust. But some other criteria, some other of course depending on its size, the cost, resources, everything spent will be more. So normally we will have a trade-off between these two. accordingly, whether you want more and more reliability or you are ready to spend more cost, accordingly the connection will be made in practical scenario. Now each station attaches to the node, and collection of nodes is referred to as a communication network, that the part of the entire network where the switches or the switch nodes are connected to each other is called the communication network, because it is making the communication possible between the end devices or the stations. Now in a switched communication network, the data enter in the network from a station and are routed. So you can see that routed is actually, if you are looking at the terminology switch and route is something used where the switching is done in a more intelligent way. That means some kind of routing algorithm will be running on the background, and the algorithm will be deciding which outgoing link is to be chosen for transmitting your information. Like in the previous example, whether it is sent to 5 or 7, that will be decided by the algorithm which is being run on the background, and the parameters which are being used by the algorithm will be different things like the current traffic congestion, other reliability, or maybe a link is failed. Everything will be updated by the algorithm, and accordingly it will decide the switching process in a more intelligent way. That is where the term routing comes. But in textbook and all, the switching and routing are normally used interchangeably, but this is a correct switching. Simply it is choosing one of the outgoing link. It will only ensure that if I am choosing this link, information will be delivered at the receiver. Like in the previous example, if node 4 switch 4 is selecting switch 1 as the next one, definitely the information is not going to be delivered to F, that end station F. That part, up to that part, the decision making will be done by a normal switch. But if it is doing something beyond that, it is intelligently selecting a particular path for transmitting your information by running some smart algorithm on the background. In that context, you can use the term routing, okay, switching and routing. But it may be used interchangeably also in textbook. To the destination by being switched from one node to another. So for example, in the figure, data from station A, which is intended for the destination F, are sent to node 4. They may then be routed via node 5 and 6 or node 7 and 6 to the destination, because both are leading us to the end machine. As the number of paths between the source and destination increases, means more reliability is there, because if there is any problem with one of the paths, still we can depend on the other one. So some more observations here. So if you see that some nodes connect only to other nodes, right? For example, that 5 and 7, you just refer that figure, you can see that this 5 and 7, they are means they are not connected to the end system, that's all. Sometimes the nodes, in the sense the switching nodes, are connected between switching nodes, and they are used exclusively for the routing or the switching purpose. And some nodes are just connected to the end stations also, some kind of terminal switches, okay. So their sole task is the internal switching of data, because they are not connected to any terminal end machines. They are exclusively for the routing purpose. We are deploying them exclusively for the routing purpose. And the other nodes have one or more stations attached as well. Station in the sense the end device, in addition to their switching functionality. So they are doing multiple roles. From the end devices, they may be accepting information, or they may deliver the information to the end device, and at the same time they will do the switching also to the successive switches. Such nodes accept data from and deliver data to the attached station, and they will do additional switching function even. Now if you are looking at the node to station link, or if you are looking at the node to node link, node to node in the sense that dedicated node devices, they are communicating just for the switching purpose. Station to node link means from the station, information the station is trying to deliver to someone else, or from the node the information is being delivered to the station. So that is happening at the end portion. So if you are looking at this node to station link, they are normally dedicated point to point direct link, because the end station can be directly connected to the node. Now if you are looking at the node to node link, they are normally multiplexed, because if you see that in a particular switch, multiple end machines will be connected, and from all these end machine, information will be coming, and all those information together one may want to be traveled through a single outgoing link of the switch, and that time the media which is used between these two nodes, switching nodes, we may force to share. and in that case you can either use that frequency division multiplexing or the time division multiplexing, which we already covered in our module 5. That concept is already clear for you at this point. Okay, so right now you know what is why we have to multiplex, because we want to share that particular resource, that particular link. We want to allocate that for a number of end station which are connected to those particular end terminal switching node. Okay, so if you are looking at the station to node or the node to station connection, that is typically the point to point direct link, and where we just a single connection, right? We don't want to multiplex it, we don't want to share it. Okay, but if you are looking at the node to node link, between these nodes multiple devices will be connected, and we want to share that dedicated link among all these end station which are connected to that particular switching node, and that time we need this multiplexing process, and that time which is convenient for you or which is your requirement, you can choose either FDM or TDM technique. Now usually the network is not fully connected, like I already told you. If you have a fully connected network, that is our mesh network, then it is very 100% reliable and all, but that is very costly, and that is there is not a direct link between every possible pair of nodes. If there is that link between every possible pair of nodes, it is called a fully connected link. If it is not fully connected, if there is no direct link between every pair of nodes, then it is always desirable to have as we don't have direct connection between every pair of devices, so at least we need direct path, as well as we wish to have more than one path. Path in the sense, connection of I mean direct links together make a path, right? For example, in that previous figure, we have a path from A to F, and that path is going from A to the node number 4. You go to that figure and see it. A to node number 4, then node number 4 to node number 5, node number 5 to node number 6, and finally from node number 6 to the end station F. That complete portion is called a path, right? We have a path A, from the path is like node number A to station A to node 4, then node 4 to node 6, then node 5, and node 5 to node 6, and finally from 6 to the end station F. Together, all those links together make the path. So we wish to have more than one such a path. In that example, we got two different paths, right, between A and F. More than one possible path through the network for each pair of station, then definitely we have more reliability. So that enhances the overall reliability of the network. So that is the thing. So some observations. So this is about the basic idea. Hope you got a basic understanding about the switching process, and at the same time I want to highlight that terminology, switching and routing, which as I already told you, routing is something more than the switching actually, but in textbook and all the people are using those both the term interchangeably. Simply we want to make our communication possible, that's all. And how it is done? By means of the switching technique. Now in the subsequent part we will move on to the classification and how this is done. You will get a more insight into the topic after covering the subsequent parts. Okay, thank you.